We'll now look at matrices and how they're related to systems of equations. So we're going to start with this system, x plus y equal to 5, and 2x minus 3y equal to 0. And we want to try to simplify this and solve it. So if you learned how to solve equations before, you may want to start by multiplying the first row, the first equation, by -2. And then we can add these. This gives us 0x minus 5y is equal to -10. Your next thought may be to divide by -5 to get 0x plus y equal to 2. So now that we've done that, we're actually going to replace the second equation with this new one we just found. So now I'll multiply this second equation by -1. This gives me x plus y is equal to 5, and 0x minus y is equal to -2. And when I add them, I get x plus 0y is equal to 3. So now my new system is x plus 0y equal to 3, and 0x minus y equal to -2. So I have my solution as 3, -2. And so the idea here is we're going to use matrices to kind of simplify this process and get rid of some of the things that we repeatedly write down over and over. So we'll start with a coefficient matrix. And this is just the matrix of coefficients. So for example, my system of equations said x plus y equal to 5 and 2x minus 3y equal to 0. So my coefficient matrix, the first row will correspond to the first equation. Coefficient of x is 1 and y is 1. The second row corresponds to the second equation. Coefficient of x is 2 and of y is -3. So this is my first equation. The second row would be my second equation. And the columns correspond to variables. Both of the first column was coefficients of x. The second column was coefficients of y. My augmented matrix, which is what we'll deal with most of the time, kind of expands this. So a coefficient matrix does give us good information. It does tell us the coefficients of the variables. However, the augmented matrix includes other information. So it starts just like the coefficient matrix. And then this equal sign in the equation will be represented by a vertical bar. And then we put the right side of the equation, the constants. And this is the augmented matrix. We augmented the coefficient matrix by adding this extra column. So we say two matrices are equivalent if they have the same solution set. So for example, if I look at the augmented matrix that I just had, 1, 1, 5, and 2, -3, 0, this is equivalent to the augmented matrix 1, 0, 3, 0, 1, 2. So this top one was the original equation, and this bottom one was the one that after we solved it, what we had. So we know that these are equivalent matrices because we've already shown that they have the same solution set. So when dealing with these, we're going to have row operations. And these are going to correspond to the different things that we were able to do to the equations in our original example. The first one is we can replace a row with the sum of itself and a multiple of another row. So we did this a lot. We would multiply the first equation. We started by multiplying it by -2 and adding it, and this is what we did, was this operation here. The second one is that we can just multiply the entries in a row by a non-zero constant. So we can multiply a row by a non-zero constant. We did this one as well. At one point we had -5x equal to -10, and we divided by -5. This would have been the same thing as multiplying by -1/5. And the final row operation that we can do is to interchange two rows. The order that I wrote down the equations in is completely irrelevant, so we can switch those up if we want to.